Ever swiped a credit card at a store or entered your card details online? You've used cryptography. Think of cryptography as the secret language of the digital world. It's like that secret language you and your best friend used to pass notes in class, only a whole lot more complex and secure. Imagine you're buying a book online. You go to your favorite online bookstore, pick the latest bestseller, and proceed to checkout. You enter your credit card details and click Buy Now. But how does your credit card information get from your laptop to the bookstore's server without getting intercepted by some sneaky character along the way? The answer is cryptography. Cryptography is like a protective bubble that surrounds your credit card information as it travels through the vast digital universe. It converts your sensitive information into gibberish that only the rightful recipient can decode. This gibberish is called a ciphertext, and the process of converting the plain text into ciphertext is called encryption. But it's not just about online transactions. Cryptography is everywhere in the digital world, from secure email communications to protecting sensitive government data. It's the invisible armor that keeps our digital lives safe and secure. Cryptography is a fascinating world of codes and puzzles, but the real magic lies in the ciphers. Ciphers are the tools of the trade in cryptography. They are the secret agents, the code breakers, the masterminds behind the scenes. They are the ones who turn plain text into ciphertext and back again, keeping our digital world spinning securely. So next time you swipe your card at a store or click Buy Now online, remember the silent guardians of your transaction, the ciphers. They are the unsung heroes in the background, tirelessly working to keep your data safe. But what are these ciphers? Well, that's a story for another time. Ciphers, in simple terms, are like secret languages or codes. Imagine you have a message, a vital piece of information that you want to keep safe. You wouldn't want anyone to just pick it up and read it, would you? That's where ciphers come into play. They transform your readable data, your open message, into something that looks like gibberish to anyone who doesn't know the secret to understanding it. Like turning hello world into kor zruog. Think of it like this. You're creating your own secret language. You and your friends could be talking in broad daylight, in the middle of a crowd, and no one would understand a word you're saying. Exciting, right? That's the beauty of ciphers. It's not just about hiding your messages, but also about the thrill of creating and decoding these secret codes. Now here's the thing. Ciphers aren't just one size fits all. There are different types of ciphers, each with their own unique ways of transforming data. Two of the most common types are substitution and transposition ciphers. Intrigued? Well, think of substitution ciphers as a game of disguise. Each letter or symbol in your message gets replaced by another letter or symbol. It's like your message is wearing a costume to hide its true identity. On the other hand, transposition ciphers are all about shuffling. They take your original message and rearrange the letters in a specific way. It's like a puzzle where you need to know the correct order to put the pieces back together. However, these are just the basics. There's a whole universe of ciphers out there, each more fascinating than the last. And they all serve the same purpose, to keep your information safe and secure, and to keep the thrill of the secret alive. From secret languages to scrambled messages, ciphers come in different types. Let's dive a bit deeper. Scene script. Imagine a secret language where you replace each letter with another one. That's a substitution cipher. Now let's delve into the fascinating world of substitution ciphers. Picture a world where every letter of the alphabet has a secret alter ego. In this world, A might be Z, and B might be X. Seems like a neat trick, right? This is the essence of a substitution cipher. It's a method of encoding where each letter in the plaintext is replaced by a letter with a fixed number of positions down the alphabet. One of the most famous substitution ciphers you might have heard of is the Caesar cipher. Named after Julius Caesar, who reportedly used it for his private correspondence, the Caesar cipher is a type of substitution cipher where each letter in the plaintext is shifted a certain number of places down the alphabet. For example, with a shift of 3, A would be replaced by D, B would become E, and so on. Substitution ciphers are not just relics of the past, though. They still find their use in modern times, especially in the realm of puzzle games and introductory cryptography lessons. They are a perfect starting point for anyone keen on learning about cryptology due to their simplicity and ease of understanding. But don't be fooled by their simplicity. These ciphers can be incredibly potent when used correctly. For instance, the Vigenère cipher, a form of polyalphabetic substitution, was considered uncrackable for nearly 3 centuries. It employs a series of different Caesar ciphers based on the letters of a keyword, adding an extra layer of complexity to the simple substitution method. So, the next time you come across a series of seemingly random letters, give this a thought. It might just be a simple substitution cipher, waiting to be decoded. Remember, in the world of cryptography, every letter holds a secret. Substitution ciphers are like simple secret languages, but some ciphers scramble instead of substitute. Ever played word jumble puzzles? Transposition ciphers work similarly. Now imagine that instead of unscrambling a single word, you have to unscramble an entire message. With transposition ciphers, the letters themselves remain unchanged. However, their positions within the message are shuffled around, leaving you with a jumbled mess that looks nothing like the original. Transposition ciphers are like complex word jumble puzzles. Instead of substituting one letter for another, like in substitution ciphers, they rearrange the order of the letters. This jumbled up mess may seem like gibberish at first glance, but once you know the key, it's just like solving a word puzzle. Let's take an example. If the original message was "Hello World," a simple transposition cipher might rearrange the letters according to a predefined rule, like reversing the order, to give us "Diel Rao Ola." Can you see the difference? The same letters are there, but their order has been changed. But of course, transposition ciphers aren't as simple as reversing the order of letters. They can be much more complex, involving multiple rounds of shuffling, different rules for different parts of the message, and even combining transposition with substitution for an extra layer of security. Despite their complexity, transposition ciphers have their uses. They're often used in combination with other types of ciphers to create more secure encryption. In the world of cryptography, the more complex the cipher, the harder it is to crack. But remember, even the most complex cipher isn't uncrackable. Cryptanalysis, the science of cracking codes, has come a long way. With enough time, resources, and determination, even the toughest cipher can be broken. Transposition ciphers add a twist to the secret language, but regardless of the type, all ciphers have a common goal. They are all designed to keep information safe and secure, to prevent unauthorized access, and to add a layer of mystery to our communications. Because at the end of the day, who doesn't love a good puzzle? Whether substituting or scrambling, ciphers aim to secure information. They are the invisible guardians, the intangible shields that protect our digital transactions, ensuring that our secrets remain hidden in plain sight. Ciphers are more than just complex puzzles. They're integral to the world of cryptography. From securing your online bank transactions to protecting military secrets, ciphers are at the heart of digital security. They're the alchemists of cryptography, turning plain text into an unintelligible jumble of characters, but they also hold the key to reversing the process, transforming the gibberish back into meaningful information. Consider this. Every time you type in your credit card number to buy something online, your information isn't just flying through the internet in a form that anyone could read. Instead, it's scrambled, converted into a code that's meaningless to anyone who doesn't have the key. That's the magic of ciphers. They help to ensure that even if your information falls into the wrong hands, it won't be of any use. But of course, like any good magic trick, ciphers aren't infallible. That's where cryptanalysis comes in, the art and science of cracking codes. Cryptanalysts are the detectives of the digital world, using a mix of logic, intuition, and sheer computing power to try and reverse engineer ciphers. They're like locksmiths, trying to pick the lock without the key. Cryptanalysis is a crucial part of maintaining digital security. By testing and probing the strength of ciphers, cryptanalysts help to ensure that our digital defenses remain robust. They keep the codemakers on their toes, constantly pushing for stronger, more secure ciphers. In essence, ciphers and cryptanalysis are two sides of the same coin, a dynamic duo in the world of cryptography. They're locked in an eternal dance, each one constantly trying to outwit the other. But at the end of the day, their goal is the same: to keep your information safe. In the world of cryptography, ciphers are the silent protectors of your digital secrets.